All right, Harmony Science Academy AP Statistics students, let's get into the exam quick cheat sheet video. And really that's the main focus, wrap up the semester. We've come this far, let's go and put our best foot forward. And the vocabulary, kind of comically, but in a real sense, very important. Integrity, okay, got to do what we got to do. Teamwork, we're all in this together. Leadership, okay, that's each individual, one of you guys, to put your best foot forward. And creativity, right, embedded with that IQ of yours. All right, and before we get into the formula sheet and tables, which is going to be very, very helpful, let's go and just touch base here on some TI Nspire highlights, okay, that are going to be very helpful. All right, we're going to be looking at 6 of these TI Nspire highlights. Okay, they're going to come at you really fast. You can rewind the video or whatnot. The first one here is going to be on regression analysis, right? Surely you're going to have data come at you. Something along the lines of explanatory values and response values, okay? So let's go and go through those steps here. Essentially, you'd have your scatter plot, really, so you can produce your regression model, see if it fits the data, okay? Okay, on this highlight number 2, we've been here many times with normal probabilities, right? We know we're going to be asked this. So let's create this scenario where you're asked to find the probability that X falls between two values, 65 and 86. Okay, we know that X is normally distributed. That's key here. The mean is 70 and the standard deviation is 15. Let's go ahead and watch what that looks like in the TI Nspire here. Okay, in this next example, we're going to be looking at binomial probabilities. The specific scenario is something like this. You've got 10 coin flips, and what is the probability of you getting exactly 5 heads? Okay, now there is, pay attention, 2 options that we typically come across, a PDF and a CDF, right? We see that a lot. Here's the simple way to consider that. If we cared about 5 or more, okay, heads, right? That would be a cumulative type of process, so that's CDF. And if all you care about is exactly 5 heads out of 10 coin flips, that'd be PDF. So hopefully that helps, and let's go and take a look at that. All right, in this highlight number 4, of course, we're going to be looking at random variables, and we'll be asked to do things like produce a mean, a standard deviation. So just in front of us, we have 2 columns. One of them is basically that random variable, right, the values, and their associated frequencies. Okay, so let's go and run that here. This one's pretty quick. Okay, in this next example, highlight number 5, we're going to be checking conditions. So as we see in front of us, we've got a series of means or averages, and we want to infer, okay, we want to go ahead and look at the relative shape, so on and so forth. A box plot and a histogram would, would be very valuable here. So let's go ahead and take a look at that. Alright, next let's go ahead and get into the formulas and tables for AP Statistics that will be provided for you guys. Again, the whole purpose here is to make this video as short as possible, so let's go and get into it, okay? Now, something that I can highlight here real quick is this would essentially be one variable type of stats, okay? So one variable statistics. This, as you guys can see, is two variable statistics, okay? Don't overcomplicate this. Again, you guys are far away from calculus, so this is right up your alley. A lot of other stat students that are, have been studying are going to make trouble with their algebra. You guys are going to cash in with your math skills, okay? So, anyways, this is just the mean, okay? The calculator is going to basically compute that for you, but you really want to understand here in case you're asked to make interpretations. Same thing with the standard deviation. Okay, that's all this is. You won't be asked to do it by hand, but of course the calculator can do it, and you can use it to interpret in some capacity. Okay, as far as this goes, pay attention. We're trying to make this as simple as possible. This is nothing other than y equals mx plus b, right? So it's related to that whole linear regression aspect. Okay, so with that said, when you see y hat, this hat means it's an estimate. Okay, here you've basically got your y-intercept and you've got your slope. Okay, now as far as these two here, okay, this is a situation where you'll be given information, literally y bar, x bar. This is the standard deviation for y, for x. Okay, this is r, the correlational coefficient. Okay, it would be provided for you, so you can do some algebra to produce these. Okay, and then of course this intimidating looking formula is for the correlational coefficient r. Okay, it's very intense. All that matters to you is that you're not going to have to break it down by hand. But if you're asked, hey, what impact would a change in this standard deviation have on the formula, you can make those conclusions. So staring at that's going to help you. Okay, I think with that, we're good. And just so you don't feel cheated, so again, this is basically just some fancy formula for slope. This is correlation, in case you want to do a quick peek. Again, since we're looking at two variables here, things that should come to mind are scatter plots. I'll just put scatter plots and the whole explanatory response type of environment. Okay. Other than that, if you are summoned to use this kind of formula, you want to be very deliberate and identify what these represent in context. Okay, alright, I think now we can move on. Alright, on this part of the formula, the second part, probability and distribution, this first part, maybe I should go over it. Okay, we read it as conditional probability. Okay, and a couple of things is, first of all, this bad boy right here, we would read it as or. Okay, we talked about this one. You would read that as and this guy right here is A given B has occurred. Once again, a lot of people might be asked questions that they get wrong. Why? Because you can do a lot of algebra with this. So for example here, okay, if they're asking you what is the probability of A intersect B, okay, well, in this case, algebraically, all you'd have to do is multiply both sides by probability of B. It'd cancel, and apparently they'd give you at least some information. You'd input it and be able to process that way, okay? Same thing with this side. You can add it to this side and play all sorts of algebra tricks on that. The other thing to keep in mind is the word independent, okay? Independent means that these events, when you have two events or more, they don't affect the outcome of one another. Okay, so that's how you know you have independent. And the other one is disjoint, if that word pops up. Okay, That's pretty synonymous with mutually exclusive. So basically two things that cannot occur at the same time. So for example, being a freshman and a sophomore, you can't be that at the same time. Okay. All right, let's go and continue. Now I get it. All of this looks or could look intimidating, but let's go ahead and simplify it because we've been here before. Okay. So discrete random variable x. Okay. So when we see that x, that's what we're identifying. So discrete random variables, so things that take on values like 1, 2, 3. Okay. You can't permit a fraction, right? 1.115. So those kind of variables, okay, would be considered discrete. So for example, how many shots you make, you either make one shot or two shots, you don't make 1.3285 or something like that, okay? So again, these are just formulas. You shouldn't be bogged down, okay? Essentially, we can almost erase them because the calculator does it for you, but understanding them, right? So this is the summing of what? Of that particular value plus its frequency. Okay, we've seen that. We've seen the calculator do that, right? That's the whole, L1, L2 process in the calculator, and then it spits out all that data. Okay. What else needs to be said here? Pretty valuable, guys, is again when we talk about probability distribution. They're going to ask you, and again, we're not even talking FRQ, okay? But if you're going to be bold and take those on, even for the MCQs, when it comes to probability distribution, they ask you to describe center, spread, and shape, okay? So this right here is your center, okay? This right here would be your spread. And these bad boys all along here would be your shape. Okay. All right. So what else can be said here? So we discussed this one. Let's see where we're at. Now this, right, the key phrase here is expected value. We've seen that before. So let's go and put that on here. So again, this formula sheet is going to be available to you, and immediately you see that E, you're like, oh, expected value. Now it's friendlier, okay? Again, you don't need the formulas, but if you're asked to make some kind of interpretation, understanding what they do is going to work perfectly, okay? So now these two are very much kind of juxtaposed. So let's go and look at binomial, okay? Now in this case, let's see here, see if I can, I guess I'll put on this side. If you guys think back to our textbook, there was something with these initials, bits, okay? So, in case you're curious, this was binary outcomes, right? Failure, success, okay? So that's how they're related. The I was for independent trials. So as long as that's preserved, you're good. The S was for, what is it? Let me think back here. It's the same value for P for all trials. Okay, so basically they preserve the same probability. Okay, so that's the same across the board. So this N and T is what makes them different. This N basically says that you have a fixed amount of trials that you're going to run and kind of calculate the successes in that amount of trials. Okay, now in this one you're going to run trials until you get to your first success. Okay, so hopefully that's clear. Okay, so something numerically speaking, you might have something like this. Let's say go back here. There it is. All right. Go back to red. All right. So this would be n number of trials. I don't know, let's say 5. And what is the number of successes we're looking for? Okay, P would be the probability. So I don't know, let's say 0.2 for the heck of it. Okay, as far as X is concerned, we'd have, right, 0.2 would be for the successes. Okay, X we've already determined is the number of successes. 1 minus P is essentially failures. Okay, so 0.8. And then just kind of do the 5 trials minus 3, which is 2. So again, very intuitive. Hopefully that helps big time. So just knowing N and P, right, probability trials, it's going to let you pretty much compute the standard deviation, the mean for binomial distribution, and with geometric, the same thing. Okay, here you have the failures, and you're going to go ahead and take the identified success minus 1 and times the percentage for that success. Okay. So to illustrate it, hopefully a lot easier than the words I just kind of spewed there. Let's say you've got these failure, and then finally you have a success. I guess if we use something similar to above there, you'd have 0.08 to the 3rd power, and then we finally have our success in this case, okay, according to that distribution. Alright, let's go and move on. Alright, on the 3rd part of the formula sheet is sampling distributions and inferential statistics. This, we recognize it by the phrase significance test. Okay, at least from our textbook reading. This is, as it spells out, our confidence interval. Okay, what we associated here is our Z or T values, and down here was our Z star or our T star. Okay, our criticals values. And what else can be said? We didn't cover this, so I'm not going to go into any detail on that. Let's see here, besides saying that this is that whole chi-square test. So if you're bold enough, or maybe you did read ahead, you can go and apply this formula. Okay, pretty straightforward. Alright, let's continue here. Alright, so yes, number 3, sampling distribution and inferential statistics continued. Okay. Again, what are we looking at in general? So here we have the mean, standard deviation, standard error. Okay, and if I don't say it later, notice I said standard error with this star up here. Okay, that's related to your Z star and your T star. Okay, so I'll make reference of that in a bit here. So a couple of things that we can make note of. This bad boy right here is your statistic. Okay. So that should, ring a bell. What else is there? This is your significance test. Right? At least the textbook language introduced it that way to us. What else do we know? Once again, we'll repeat the mean. Okay, it gives you an idea of the center. Here, standard deviation, the spread. Okay, and again, you may not have it all come full circle, but again, in little pieces, right? A lot of this pecks at your knowledge base, so that's kind of what we're doing here. Let's see here. Now, this is one population, but again, in context, this might be 1 sample, 2 sample. Okay, so here I'm gonna focus on the 1 sample, 1 population. As far as it being 2 population, 2 sample, you guys, it might not be the most intuitive, so just follow it verbatim. Okay, but a couple of things to highlight would be Z. Okay, as we had looked and read through the textbook, we know it's basically P hat, and this is again an estimate when you got the hat, minus P over the standard deviation of P hat. Okay. What else did we cover? Let's see here. What else can be said here? Okay, so this can be used with a confidence interval. Okay, that's all I can kind of squeeze in there, right? We talked about, or we read about confidence intervals. So when appropriate, this is really a simple of a formula as it gets for that. Okay. So we got p hat plus or minus z star times the standard deviation for p hat. Okay. So basically it's just identifying what each one of these is and substituting so we can produce the confidence interval. And without belaboring it too much, let's move on to this was the sampling distribution for proportions, population proportions, and we had read the sampling distribution for means. Okay, so let's go ahead and kind of highlight some of what we just did there. Let's see here. So again, we've got one population, two population, or one sample, two sample. Okay, when we're regarding the mean. Okay, something that I'll really highlight in a little bit, as I will do here. Okay, since we're dealing with means, we're going to be working with t as opposed to z. Okay, so that's something you want to make note of. And through the examples we did from the textbook, you had x bar minus mu over s over the square root of n. Okay. Let's see here. What else can be said? Okay, as far as confidence intervals, when appropriate, I can go ahead and work it out with x bar plus or minus, no difference than what we found in the textbook. Okay. Again, mean, center, spread, standard deviation, you've got your standard error. Okay, so there's again the star, introducing t star. What else can we say here? Again, not very intuitive here for the two sample, but you guys can go ahead and just follow it verbatim if appropriate. And I think we can go ahead and slide down this way. Alright, this third part in this section, sampling distributions for simple linear regression. We ran out of time, but again, it's comfortable context for us. Okay, it's just regarding slope b. There's some formulas here, most of them absolutely you will not have to follow, but if you're asked some kind of MCQ question about an interpretation, then that's what you would refer them to. The only thing worth mentioning is in this context, the degrees of freedom is uniquely n minus 2. Okay. All right. So now let's go ahead and move on to the tables. Okay, so we're looking at table A. We've referenced this in the past. So bottom line, how do I know to use table A? I'm working with Z. Okay. As far as all these values in here, okay, these are basically areas. Areas where? To the left of Z. Okay, so it goes negative, turns positive. Whoops. I think I left off that portion, but yeah, the Z values do go into positive, which would move Z about this direction, and it would still be the area to the left. If you want the other side, okay, the area on the other side, just take 1 minus this given area and you'll have it. Okay, so you've got your probabilities, your z-scores, table AZ. As far as table B, how do we know to use this one? You're working with T. Same thing, these are areas. Notice that it's to the right in this case. You've got your degrees of freedom on the left side, your probabilities. Now keep in mind that if for some reason you're caught here towards the end where it starts kind of jumping some degrees of freedom, You want to round down, okay? That's kind of the rule of thumb there. Here also you have your tail probability, so 4.025, okay? We go straight down, you've got a 95% confidence level. So that's exactly because we've got two tails, right? One to the left, one to the right. Keep that in mind. And as far as chi-square, another casualty for us having run out of time. But you know, if you're gonna muscle through something, you do have this chi-squared. You've got your area to the right. Notice that there is a skewness, okay, here towards the tail. You've got your degrees of freedom. And I think that's more than should be said since we did not get to chi-square. Okay, so this part could be extremely valuable. What is not on the AP Statistics formula sheet that you might want to kind of stow away somewhere in that brain of yours? Okay, give me one sec. Okay, so this isn't necessarily a formula, but we've seen it on multiple instances where there was what they call a Minitab computer output, computer rendering. Okay, let's make it simple. So this bad boy right here, and always to the left. Okay, so the focus is going to be under coefficients. Okay, this is simply going to be slope. Okay, talking about correlational coefficients. This guy's your y-intercept. Okay, this is in large part your main focus. Okay, this part in terms of, you know, hypothesis testing. Okay, if they, you know, put you in that environment, you can kind of scope that out. What else needs to be said? R squared is this value in this case. You can take the square root to get R, and here is the standard deviation. So really, everything else you can kind of disregard. Alright, and what else is not going to be on the AP stats formula sheet? Okay, we mentioned it the other day in class. You're going to see IQR somewhere in some context. That's simply Q3 minus Q1. You guys can get the rendering on the calculator. As far as kind of like bonus outliers, okay, remember that you can multiply the IQR times 1.5 in either direction. Anything beyond that would be considered an outlier. The residual, there's a way to calculate that. We may not have had the exact same formula in from the textbook. I don't remember exactly that. Okay. Let's see here. And I guess the last thing to mention is label all variables. I think that's going to be one of the biggest takeaways for you guys is that if you introduce a label, even if it's standard in a formula, label it. Let them know you know exactly what you're talking about. And lastly, let's kind of throw out some AP Stats review top 15 most forgotten confused topics to refresh. Really quick, you can pause the video to kind of spend some time there if need be. Adding variances is possible. Cannot add standard deviations. Kind of look at that square root sign. That'll tell you the story. Let's keep going. As far as the power, we talked about the power. What's going to increase power? The sample size or the significance level. Two-sided test, don't forget to double the p-value. Conditions checking, if you're doing a test or an interval, maybe it'll say assume conditions have been met. So that does happen. Be aware of that. You don't have to be redundant. There's no credit for that. So let's hope we get a healthy dose of that. Normal conditioning, you've got different scenarios, right? The trials, the probabilities, but keep in mind that they must all be greater than or equal to 10. We saw that over and over. Normal condition, you want to check the population distribution. You would definitely want to check the central limit theory. Is n greater than equal to 30? And as far as checking, let's say, data through a box plot, you want to be looking for skewness, outliers, things of that sort. Chi-square, didn't get there unfortunately. Binomial conditions, again binomial, success, failure, win, lose, okay? or binary. I think I had mentioned it that way. Independent, knowing one outcome doesn't affect the other. With bins, okay, this was for binomial, okay, because you've got a set number of trials, and in there you've got a host of successes, unlike geometric where you run all the failures till you get to your first success, and then as success probability, the same probability, okay. All right, 7, as we're wrapping up here, you've got some algebra, as we talked about here, that you can perform on these probabilities, formulas. Let's see here, Z star versus Z star versus T star, definitely for proportions, or if theta is known. If theta is not known, you can go T star. Let's see here, different degrees of freedom. In general, it's just n minus 1, but we did introduce that one case where it's n minus 2. Very importantly, I'm sure it'll be tested. You can try and retain both of them, but it gets kind of messy, so here's the bottom line. We're supposed to reject the null hypothesis, right? That's standard practice. So the type 1 error is, hey, we did our job, we rejected the null. Why is it an error? Because we shouldn't have, okay? I think once you memorize type 1, I think you can produce type 2. 3, cluster versus stratified. Cluster is my small microcosm of entire population. That just means you've got basically a smaller portion that is a true representation of the population versus stratified homogeneous groups, which would be something like dividing between freshmen, sophomores, juniors, and seniors. When taking a sample, keep in mind that the standard deviation decreases while we're sampling. Okay, and lastly, okay, random generator, what you want to ultimately find out is there replacement or not replacement in case you are asked to produce a random list. Alright guys, I think that's it. What do I have left? Alright, we are done. Appreciate your time, and hopefully this all helps.